Well, good day, viewers. I don't usually work on this stuff, and if I need to lift it, we're going to be hooped here. 2001 F550. It's got the Power Stroke diesel, and it's got a number of issues. Check engine light is on, as amongst other lights, ABS and airbag warning light, and it has low power. And it's had a number of sensors replaced on it, turbo boost sensor or pressure sensor or something. Exhaust gas back pressure sensor has been replaced. To me, it feels like it has a miss when I run it, so I'm going to scan it and we'll see if there's any fault codes in it, what codes are present, and we'll look at cylinder contribution. Feels like it's got a dead cylinder to me. So we've got the key on, engine off, and we're going to do a network code scan and see what codes it generates. Got a battery charger on it so the batteries don't go low while we're scanning it. Why is it not picking up anything? Oh, this is a good start. That's the little vacuum pump for the, I believe, accessory delay relay, ignition key fault, wiper mode select switch, washer delay switch. What about the rest of the computers in here? Well, isn't that special? Automatic with air conditioning, it's manual with air conditioning. Why didn't it scan the ECM? No communication. Let me go make sure I got the key on. Okay, I cycled the key. I manually entered the VIN. Okay, here we go. Turbocharger boost sensor A circuit low, coolant circuit high, injector driver module codes detected. So let's go into the injector driver module. Why isn't it there? Do I have to fire up IDS? Let's do a Coolant engine off self-test. Baby. 1 sec. So P1273, cylinder 3, high to low side open. So there's an injector problem or something. So here's the results of the Coolant engine off self-test. P0237 turbo boost sensor A circuit low, P0118 ECT circuit high, and P1273 cylinder 3 D high to low side open. So that to me is an injector problem that could result in a misfire. So I'm going to do a little research to see what's common for these codes. So I'm going to clear the codes from the controllers. And then I'm going to do an injector buzz test. AC is off, key is on, wait for the vacuum pump to stop running. Okay, key on, engine off, injector buzz test. Well, they all buzzed. Let's see what codes it said after this test. No codes present. Well, let's do a cylinder contribution test and see what the running contribution is like. Oh, I didn't start it. This doesn't show you the live misfire graphic like the 6 liters do, but you can hear this thing definitely has a miss in it. I don't think there's any way to do a cylinder cutout test on the 7.3. I'm curious as to whether or not it mentions cylinder number 3 at the end of this test. Well, I'll pick up when we get to the end of this test. Oh, there we go. Cylinder 1 contribution balance fault, cylinder 3 contribution balance fault. Maybe we should do a relative compression test before we get carried away here. You can hear this thing doesn't sound normal to me. Definitely shaking. So I'm going to do a relative compression test before we get carried away here and spend a bunch of time. So here's my setup for a relative compression test. I got an amp clamp over the positive battery cable which goes down to the starter. I disconnected the control wire off of the starter solenoid over here, and I've got a remote start button connected to the power feed wire here and the control wire on the starter solenoid, and I've got the graphing multimeter set up to graph 500 millivolts, which is 500 amps at a 1-to-1 ratio here, over 1 second, and we're going to crank it and listen to the way it sounds and look at the cranking current. So here we go, about to crank it. And I can pause this. So it looks relatively even. 1, 2, 3, 4, 5, 6, 7, 8. It's cranking pretty fast, which is good. Let's slow down the time base here. Let's see if I can go a half a second. No, I can't. Definitely no completely missing humps there. That one's a little lower, but nothing conclusive, and it sounds normal. So let's investigate the rest of the codes. So I want to see if any codes came back. Let's see the memory codes. Just those 2 codes, no injector driver codes. Let's do a Connect key on engine running self-test. I'm going to try a running self-test and see what code set. I looked at data parameters, I don't see anything out of range right now. It might be a little too cool. Step on the brake. Well, the new code, exhaust pressure control valve performance. Oh well. So I'm exploring this P0237 turbo boost sensor A. Looking at data parameters here. Barometric pressure looks normal. Exhaust back pressure looks normal. Voltage from the back pressure sensor looks normal. But I don't see boost pressure here. Map PSI, 14 PSI. Let's see what the map voltage is. Map frequency, 0. Oh yes. They convert it to a frequency. Now I can't remember if it's actually in a frequency or if it's analog on this thing because it's a diesel. But it shouldn't be 0 frequency. It should be roughly 155 hertz. Well, looking at the troubleshooting in here, it shows pin 79, which is the light green and black wire, should be the signal wire from the map sensor. And I'm measuring it with a multimeter and it's 0. I'll double check that. So here's the map sensor here, and there's the connector for it. The middle wire is the signal wire, and with that sensor unplugged I got 5 volts on the reference wire, 0 and 0. I tried to use my variable resistor box to simulate a valid signal, but no matter where I set the resistor box, other than open, the voltage was 0. So now I've got a test light connected to battery power, and if I probe the middle terminal, which is supposed to be the signal wire, as you can see, it lights up like that signal wire is shorted to ground. Let me show you the schematic here. So this wire, light green and black, should not be grounded right now. I wonder if I could depin that wire from the terminal. Goes from here directly to the ECM, and the ECM's over in the left inner fender skirt. So I decided I would explore the P0118 coolant circuit high to see if it was related to the map sensor or boost pressure sensor code. And looking at the data list here, there is no data parameter related to coolant temperature. Why is that, Snap-on? Just like there was no data parameter related to boost pressure. Sure, it exists. Yeah, no coolant temperature reading. There's intake air temperature right there in degrees Celsius, and a voltage, 3.06 volts. It looks realistic. And there's oil temperature, 52 Celsius, and a voltage of 2.43 volts, but no coolant temperature. Isn't that weird? That vacuum pump is irritating. So that's the coolant temp sensor right there, and I'm measuring voltage on both pins, and it's 0. Let's try moving it to the other pin. 0.01. Let's try disconnecting it. Now it's saying that the voltage is too high. Now it should be 5 volts on one wire and 0 volts on the other wire. I'm going to set up here. On that pin, disconnected at 0 volts, and on this pin, disconnected at 0 volts. So why would that be high voltage? That should be low voltage. This truck is full of all kinds of mysteries. The 2 wires at this connector are red and white and yellow. It might be yellow black. Definitely yellow and red. Red, white, and yellow, red. So here's one schematic I found. It shows the engine temperature sensor, red, white, and yellow, red. Yellow, red goes to ground, but that one shows as an input to the instrument cluster. I should still have a voltage on that wire, I would expect, on the red-white wire. Now normally a temp sensor is high resistance when it's cold, so an open circuit would be cold. Now if I look at this diagram, it's also a 7.3 diesel. It shows coolant temp sensor circuit, and it shows orange black and gray red, and that's an input to the PCM, and it shows for a manual transmission and an automatic transmission. So much misinformation in here. You go into the troubleshooting chart for this P0118 and it talks about cylinder head temperature and all kinds of other wiring. I'm going to see if I can confirm that that's actually for the gauge in the dash. So with the sender unplugged, the temperature gauge on the dash reads way down at cold, and when I plug it back in it comes up to about 1/4. So that sender is definitely for this gauge in the dash. It has nothing to do with the ECM. Wow. So with the proper size probe in there, I've actually got 10 volts on that wire, 10.26 volts on that red-white wire. But that's coming from the instrument cluster, so it's got nothing to do with the coolant temperature. So backpinning that red-white wire, I got 4.58 volts on that temp sensor. Let's move the terminals of wire harness around. It's got nothing to do with the temperature in the engine control computer. So I wonder what temp sensor they're referring to. So I'm going to go back and do a key on engine off self-test again. I'm going to clear all the codes. Codes menu. Clear codes. Yes. Continue. I got the map sensor plugged back in again. And let's try this key on engine off self-test. Key is on. Battery charger is on it. See, it's only 11.9 volts. So we still have the turbocharger boost sensor A circuit low and ECT circuit high input. I wonder if I can check the VIN number in this ECM. I wonder if it's got somebody put a used ECM in here and it's got the wrong. Do they have the VIN number? Module ID. Maybe not available. Wow, that's interesting. This truck is not tuned. I asked him that. Can't get VIN number out of this thing. I had to manually enter it. Interesting. So right in the middle of the screen now you can see the bolt that holds the connector for the ECM. It's behind the left rear wheel well. Can't really get at it from the top, so I'm going to have to take the inner fender skirt out. But I think what I'm going to do is I'm going to put a test light on that wire to the map sensor signal and watch for that test light to go out while I'm manipulating the harness. So I got my test light hooked up to the boost pressure sensor signal wire, and it's lit up as you can see over there, and I was going to manipulate the harness to see if I could get it to blink or flicker or do anything. I'm trying to reach down here. Damn. Where does that harness run? It runs over top of the engine by the looks of it. Right up here. I think. Well, we're going to take the inner fender skirt out. So I have the inner fender skirt out. That's a challenge, a bunch of bolts and some push pins. And I've got the ECM disconnected at C1027. As you can see under here, the ECM is unplugged. And that wire is still grounded somewhere. Now in the schematic it doesn't show any connectors between the ECM and that, so we can't really divide the circuit anywhere, but I'm going to try and see where that harness runs. So near as I can tell, that wiring harness runs along the roof, or along the cowl here, inside here, and then joins down in here. And it goes to pin 79, which is that terminal right at the end there. That's 79. Yes, 79. So I think I'm going to run a new wire, but I'm going to try and find out what other wire it could be compromised. I wiggled the harness, manipulated it, and I can't get the test light to go out. Let's go back here and double check this wire here. Middle wire, green and black. Focus. Well, we're just going to cut the wire down here somewhere in the loom and temporarily run another wire and see if we can get that code to go away. Well, I see some taped wire in here and a ground wire going to this stud. Don't tell me somebody's grounded that wire. Well, look what I found in here. Somebody grounded that wire. Let me get a pair of side cutters here. So here's my test light, which is currently lit. And let's cut this ground and see what happens. Imagine that. Now, why would somebody ground that wire? Somebody purposely did that. They put a shrinkable butt connector in there. Oh, it's touching the AC bracket. Well, now that that wire is not grounded anymore, let's see if the map sensor code goes away. Okay, we're going to check to see, clear the codes again. And then we'll do another key on engine off self test. ECM is reconnected, boost pressure sensor is reconnected. I can't see that fixing the intake or the coolant temp sensor code. Well, let's explore this then, see what circuit at the ECM is the ECT circuit. So looking at the data for the map sensor, which is actually the boost pressure sensor, it shows 13 psi now and 57 hertz, where before the frequency was at 0. And I think this is a calculated frequency based on the old digital map sensors that Ford used. Even though this sensor is analog, I believe it's analog, but I'm going to measure the voltage on it now that it's working. So back pinning that wire now reads 1.28 volts. So that sensor is actually an analog sensor, but because of the way Ford used to do things with their digital map sensors, they converted it to a digital frequency so that I guess the older techs who understood that wouldn't be confused. Not that this is any less confusing. 1.28 volts, 52 hertz. Imagine that. So for the coolant temp sensor circuit, according to this diagram, it shows it goes into pin 37 at the ECM. Focus. Don't want to focus. So I'm going to see if there's actually a wire there that's that color. So this is pin 27, and 10 pins in is an orange-black wire. That's pin 37. Can't read that. 52. I think that's 52 at this end. So I've got a back pin in there. I'm going to reconnect the ECM and measure the voltage on that wire. So I'm measuring 4.64 volts on that orange-black wire relative to battery ground with the key on, and I think that's too high. So we're going to ground it and see if it sets the opposite fault code. So it was setting a P0118. Now I've grounded that orange-black wire. Key on. We're going to do a key on engine off self-test again. And that wire should be low voltage now, which I think would be P0117, I think. Look at that. And that's because I disconnected the ECM. Let's clear the codes again. Try it one more time just to be safe. Let's see if there's any memory codes. It might set that code. Yeah. Okay, so somewhere that orange-black wire goes, but it doesn't go to that temp sensor on the thermostat housing or the front housing there. That one's for the dash gauge. So I'm going to look around. So I found a connector unplugged, laying down in the valley here behind this, and it's a 2-wire connector, but it's hard to tell the color of the wires. That could be red, that could be orange. But I'm going to disconnect the ground wire from that sensor wire. Well, I don't know what that is, but it's got 12 volts on one of the wires. But it's definitely supposed to be plugged in to this connector at the back here, whatever that is. I'm going to have to see if I can figure that out. So I plugged that connector in. I don't think it's the wires that are in question. Let's clear the codes. And let's do memory codes again and see if that P0118 came back. Yes, it did. It's because I got the ground wire off of that. So whatever that sensor was is not the coolant temp sensor or whatever is supposed to be deemed the coolant temp sensor. I'm going to look at component locations in this thing. So I don't know why this thing has to fight me. The connector on the temp sensor is C150. C150. And when I go to component locations, it doesn't have C150. It has coolant temp sensor, but that one's for the gauge and the dash we've already established. C100, C150, 158, 100, vacuum pump. Oh, I unplugged that stupid vacuum pump. I got tired of listening to it cycle. Gotta remember to plug it back in. Now it does go through another connector, C136. I wonder if that's the one on the valve cover. Well, I'm going to look for that. Actually, it's C138. It looks like the same picture. Normally they highlight the connector. C137. It's probably one of these. And it doesn't change color by the looks of it. 130, 135. Well, I'm going to keep looking. So I think C138 is that big bulkhead connector on the left top of the left valve cover. It is circuit 923. 923. Did I read it wrong? Circuit 923. It doesn't give me the pin location on this diagram. It says connector 138 Circuit 923, unless I'm reading the connector circuit number wrong. Sure, I gotta go back to that diagram. Yeah, it's 923. Connector 138. Connector face. It's not there. This truck is going to drive me to drink. See, there's the big rectangular connector with the bolt in it, and it's not numbered in this schematic. Oh boy. Well, I think that connector for that I found unplugged was for the either water and fuel sensor or fuel heater. Because the pressure regulator is down there and that's plugged in. So I've been searching around for a while here. I decided to use a component level testing in this Snap-on Veris Edge. And I'm going into the ECM and into ECM pinouts. And it's pin 37, that's the orange black wire. And on here, pin 37 is labeled as TFT, which would be transmission fluid temperature sensor. Now if you go back to this schematic, if I still have it up here, oh shoot, I lost it. Wiring diagrams. I'll find it again. So it shows it on automatic as going to transmission controls 29-6, circuit 923. I'm wondering if somebody put a different ECM in here and it's got the wrong programming in it and it's looking for that. And circuit 923, there it is there. Transmission fluid temperature. If it's an automatic. But according to the schematic, if it's a standard, it has a engine coolant temperature sensor. Yet, I can't find it. Almost tempted to wire in a resistor here. I'm going to try to talk to the customer, find out if that's a used ECM in there. If somebody put an ECM for an automatic, no, it would have a bunch of codes for torque converter, clutch solenoid, shift solenoids, and stuff like that as well. Unless it's a different year, and who knows. Can't get the VIN number out of the ECM. The interesting thing is in this component testing in the Veris Edge here, it doesn't list a coolant temp sensor. It lists the inlet air temperature and oil temperature, but not a coolant temperature. Wow. Let's see what the information is about. It doesn't give me the intake air temperature is used in conjunction with oil temperature to diagnose hard starting, mounted in air cleaner housing. Well, let's check the wire colors on that. So I found that sensor and I unplugged it, so I'm going to go back to the scanner here and see what kind of codes we have now. We should have an intake air temp sensor code now. Yes, we do. So I got that unplugged. So that's the intake air temp sensor. I'm going to unplug the engine oil temperature sensor too. So I think I've got the engine oil temp sensor unplugged now. And the other unplugged in. The intake air temp sensor plugged in. So I should have an oil temp sensor out of range code. I do. Now I do see one other sensor that I haven't seen before. So this is the engine oil temp sensor right on the back of the housing here. I should put some dielectric grease on that. But there's that sensor down there. I don't know what that is. And it looks fairly current. It looks like it's fairly clean, like it's been replaced or something. But the wire colors don't match. Or do they? Well, the intake air temp sensor is down there, right there. We'll put some dielectric grease on this connector. So with that connector unplugged, it has a red yellow. I thought it was red orange or orange black, but then again it could change color when it goes through that other connector. And there's 5 volts on this one wire, so I'm going to jump that. Well, first I'm going to scan it and see if I have any new codes now. So let's go back. Clear codes. Yes. Exit. Memory codes. Manifold air temperature sensor, P0118. How many frickin' temp sensors does this thing have? Oh man. So sometimes if you load information for the next model year, which is what I've done, I've loaded a 2002 F550 with a 7.3. It shows the coolant temp sensor basically the same, but it calls this connector C110. And when I click on that and go to connector view, connector face, that's that big bulkhead connector on top of the left valve cover, if it'll open. Yeah, with the bolt in it. And let's see if it lists that one with circuit 923. But there's so many exceptions, I don't see it. And it's a orange black wire. So let's go down the side here. Orange, black, orange, black, orange, black, orange, black. Orange. It's not listed there. I know what it looks like. C110. And location. Go to picture of location. There's that connector with a bolt through it, and it's not labeled, just like the other one, which was 138, I think, in the other diagram, previous year. All right, so much for that. Let's go to the coolant temp sensor itself and its location. And that was, shoot, I forgot to look at the connector view. C1064 location. C1064 shows that over here the coordinate is E4. C104, B0236, 226, but that connector doesn't exist. There's the coolant temp sensor, 1324 or 214. Coolant temp sensor 214. See, it says engine coolant temperature B10. Oh, another one. Where is that? In the thermostat? In the radiator housing? So I just got off the phone with the customer's dad, and I think we may have figured out what's been going on here. I think this engine was changed, and the engine that's in here now came out of an automatic equipped vehicle. That circuit 923 is used by automatics as a transmission fluid temperature sensor circuit. So if they put an engine in with an automatic, it doesn't actually have a coolant temp sensor other than the one for the dash gauge. So that means the wire connector has got to be somewhere on the engine. I'm going to go try and look at the original engine shortly and see if I can figure it out. I can't find where this wire goes to. See, it says with an automatic it goes transmission temp sensor, and manual it goes to engine coolant temp sensor. But all the pictures that I look at for this connector, where it is, the location of the coolant temp sensor, C150, it doesn't list it anywhere here. It shows this coolant temp sensor, but that one's for the dash gauge. We've already established that. And C150 is not on this page. A lot of these diagrams are generic, generalized. So I'm going to go run up to the customer's shop and have a look at this original engine if it's still there. So after looking at the original engine, there is the coolant temp sensor, and it lives right down below this bracket, and there is probably going to be a plug in there. This engine came out of an application that had an automatic transmission, and it doesn't use that sensor. So I suspect it won't have the wires in the engine harness side of this plug here, because there was pins, I got them written down, but I'm going to check. Those two wires for the temp sensor come up to that connector in the middle. I don't know why they're not depicted in the schematic, but they do. So, man, this is going to be fun to get at. I'm going to take some, maybe take this overflow bottle out of the way here, maybe that'll help. So that sensor lives down in the front of the engine block, underneath these pulleys. Trying to see if I can have a picture of the, let's see, I'm trying to get it on my borescope here. So you can see the plug. It's a 3/8 pipe plug. It's behind that wiring harness way down in there. So we're going to wire up this sensor, see if the wires are in the harness. I doubt they are, but we're going to wire up this sensor to that C138 connector, and I'll let him install it. He's a technician, he's a mechanic. He can take the necessary paraphernalia off the top of this engine to get at that plug, and we'll just put the sensor on top of the engine temporarily for now. So there's the connector off the valve cover. That's this connector right here, and that orange wire with the black tracer, I believe, is the wire in question. I'm going to do a continuity test back to the ECM, and I'm trying to figure out the pin layout on this connector. So that would be pin 18, and it says it's not used. So chances are this connector view is for an automatic, and like I said, with the automatic it goes down to the transmission. So let's check continuity on that pin back to this wire, pin 37 at the ECM. So pinning from pin 37 at the ECM to whatever pin that is, I think it's 18, shows continuity. Now we got to double check to see what other wire. I don't think the wire is going to be in the connector on the other half of the body, and it changes color anyways, just to make it more interesting. So the other half of the connector is circuit 359, goes to diagram 2710. Here it is here. There's circuit 359 coming from location N, goes to splice 153, and that's on the other side of the connector. Oh, maybe not. 359 goes back to K to 27.9. Let's see if that's on this page. Where's K? Oh, this is just full of fun here. Oh, there it is. So that wire should be in there. C138. And it's a gray-red wire, C138. Connector face. What did I say it was? 359, pin 19. So that should be in there because all the other wires are there. So we can't cut that wire. We need to tee into that wire. All right. that's what we're going to do. So there's the new temp sensor. I took the old temp sensor out of the old engine and the connector and routed it with enough wire harness so that you should be able to mount it down there. But that code should go to history now, so let's give it a try. So we're going to clear the codes, continue, continue, exit. Let's see if there's any memory codes now. No codes present. Let's do a key on engine off self-test. Now that still doesn't resolve the misfire problem that was going on in the engine, in my opinion. Good. Just curious. Now I had mentioned this, there's no coolant temp sensor reading in here. I wonder if there's a transmission oil temp sensor reading, because that same circuit is used for transmission oil temperature, but only on an automatic. No. Engine oil temperature, coolant temperature, intake air temperature, ambient temperature. I wonder if we re-ID this vehicle as an automatic. Engine and powertrain. Automatic with AC. Data. Continue. Transmission data. Transmission range. Engine oil temperature. Transmission fluid temperature, minus 12 Celsius. Well, that's not right. I'm going to unplug that sensor. That's interesting. It goes to 16 Celsius with the sensor unplugged. Now what? Of course, this could be bogus data. Plug it back in again. There's no coolant in it. Now it's 16 Celsius, probably because it saw an open circuit. I'll bet you there's a code. Codes menu. Memory codes. Coolant circuit high input. Let's clear the code. And let's go back and look at data again. Because once it goes out of range, it'll substitute a warm value for it. I wish they wouldn't do that, but they do. So I'm not sure if this is a valid reading because it could be misinterpreting it. Maybe the transmission fluid temp sensor has a different operating range. We're going to let it go and see if there's any other problems. Maybe tomorrow I'm going to do a key on engine running self-test. Just did a key on engine running self-test and it all passed with no codes. It actually seems to be running smoother. I'm going to take it for a road test now. So just came back from a road test. Doesn't run very well. Got no power. I'm looking at the map sensor reading. It's at 0 hertz now. It was working before after I took that grounded wire off. So this default 13 psi. It's not making any boost pressure. And I'm sure it set some fault codes. So I'm going to save this recording kind of codes it's generated. The check engine light actually flashed on once while I was driving it. Let's see what kind of codes, and it feels like it has a weak cylinder, like it has an injector problem. Yeah, so 1316 IDM codes detected. I think we got to do a key on engine off test to get those codes out of there. So let's do a key on engine off self test to see if we can get the codes out of the injector driver module. It had a 1273 code before, P1273, same code. So it probably has a problem with the valve cover gasket connector or injectors, cylinder number 3. That's why it's got a miss. And when I did the cylinder contribution test, it showed cylinder 1 and 3 weak. Yeah, the relative compression test is pretty good. But we still have a problem with the boost pressure sensor. Now I wonder if having that wire, the output wire from the sensor shorted directly to ground, killed the sensor. That's possible. Map hertz 0. Well, let's try again tomorrow.